Assalamualaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NEPS Home School. I am Sabreena Haque, Assistant Teacher of Science, National English Passion School teaching. Dear students, today I am going to take a chemistry class for class 9 student based on chapter 6, and this is the part 3 of the chapter. So let us move forward to today's topic. Dear students, today we will start from the percent composition of the element in compounds. And in gram measurement of an element in a 100 gram compound is called the percent composition of that element. This is the definition of percent composition of element in a compound, and this is the percent composition formula. How we will find out the percent composition of the element? Percent composition of an element in a compound is equal to atomic mass of the element multiplied with number of atoms multiplied with 100 divided by molecular mass of the compound. So, for finding the percent composition of an element in a compound, we have to know the molecular mass of the compound. That means first we have to know the molecular formula of that compound. Then we can find out the molecular mass of the compound. Then we have to know the atomic mass of that element and number of atoms in that compound of that element. And we have to multiply this with 100. Then we will find out the percent composition of an element in a compound. Now come to an example. Here this is the phosphoric acid H3PO4. For finding the percent composition of the element in the compound, we have to first find out the molecular mass of the compound. Here 3 hydrogen and hydrogen atomic mass is 1 plus 1 multiplied with phosphorus is 31 plus its 4 atom of oxygen and atomic mass is 16. So 3 plus 31 plus 64, that will be 98. So molecular mass of the compound is 98. Now come to hydrogen percent composition in phosphoric acid is equal to, the formula is atomic mass of the element, that means 1 multiplied with the number of the atom 3, that 3 present in, then divided by 98 and multiply with 100. If we calculate, we will get the percent composition of the hydrogen is equal to 3.06%. Now come to phosphorus. It has 31 is atomic number, it has 1 atom in the phosphoric acid, and 98 is the molecular mass of the phosphoric acid multiplied by 100. If we calculate, we will get 31.63%. Now come to the oxygen. Oxygen's atomic mass is 16, multiply the number of atom is 4, then molecular mass of phosphoric acid is 98 multiplied by 100, and we will get 65.31%. So the hydrogen percent composition in phosphoric acid is 3.06%. Phosphorus percent composition in phosphoric acid is 31.63%, and oxygen's percent composition in phosphoric acid is 65.31%. Like this way we can easily find out any elements percent composition in any compound if we know the formula of the compound and the atomic mass of that element which is present in that compound. Now come to next lesson. Next lesson is percent composition and empirical formula. We already familiar with the term molecular formula, as we have learned what it is, have the applied to determine the number of atoms of the elements in a molecule. The idea of empirical formula has been introduced to the express of ratio of various atoms in a molecules, and this is the definition of empirical formula, and this is the molecular formula. For example, there are two hydrogen atom, two oxygen atom in hydrogen peroxide. Therefore, the ratio of atoms in this compound is 1:1. That means the empirical formula of hydrogen peroxide is HO, and this formula shows the ratio of the number of atoms of different elements present in a molecule is called the empirical formula. That means the formula that shows, this is the proper definition of the empirical formula in a molecule is called that formula is shows the ratio of the number of atoms of different elements present in a molecule is called the empirical formula. And we can easily determine the empirical formula of the compound if we know the percent composition of the element in it and its relative atomic mass. Now there is the steps how we will find out the empirical formula. This part you have to learn. Now come to just now we have find out the percent composition of phosphoric acid. Now we will find out the empirical formula of the phosphoric acid from that percent composition. So empirical formula system is, we have to student. We have to find out, we have to divide the percent composition by the atomic mass of that element. That means in phosphoric acid, the percent composition of hydrogen is 3.06 and hydrogen atomic mass is 1. So its result will be 3.06. Now come to phosphorus. Then our percent composition is 31.63 and its atomic mass is 31. If we calculate, we will get 1.02 is the result of this calculation. Now come to oxygen. Oxygen percent composition, we have find out 65.31 and its atomic mass is 16. It will be 4.08. Dear students, this result come in decimal fraction. We have to convert it in the integer. So we have to divide all the number with the lowest one, and here the lowest one is 1.02. So hydrogen will be 3.06 divided by 1.02 is equal to 3. Phosphorus will be 1.02 divided by 1.02 is equal to 1, and oxygen will be 4.08 divided by 1.02 is equal to 4. So empirical formula of phosphoric acid. means is same as the previous formula. That means molecular formula and the empirical formula of phosphoric acid is same. Now come to next lesson, that means determining the molecular formula of the percent composition, and here there is the system how we will find out the empirical formula. From the empirical formula to the molecular formula from the empirical formula. That means molecular formula is equal to empirical formula multiplied with N. Empirical formula multiplied with N. Here N is equal to molecular mass of the compound divided by mass of empirical formula. Now because we have already find out the empirical formula of phosphoric acid, we will try from that empirical formula how we will find out the molecular formula. Now come to the empirical molecular formula of phosphoric acid is equal to H3PO4 by N. This is the system, and now come to N is equal to is equal to 98. We know the phosphoric acid's molecular mass is 98. So this portion is equal to 98. Now we have to find out the empirical formulas at molecular mass, that is 1 multiplied 3 plus 31 plus 4 multiplied 16 N is equal to 98, or 98 N is equal to 98, or N is equal to 98 divided by 98 equal to 1. Dear students, the value of N is equal to 1 if we put in the phosphoric acid in place of N is 1, that same formula we will get. That means empirical formula of the phosphoric acid and molecular formula of the phosphoric acid is the same. That is shown by this term. That means H3PO4 multiplied with 1, that is H3PO4. That proved that molecular formula and empirical formula of the phosphoric acid is the same number. So come for the next lesson, that is chemical reaction and chemical equation. The chemical reaction, the change which caused a substance to get a new set of properties giving up its own properties and fetus is called the chemical change. This is the definition of chemical change. We have to learn this. And the process that brings the change is called chemical reaction, and up to this much is the definition of is the chemical reaction. Now chemical equation is the short expression of chemical process by using the symbol, formula and sign. This is the definition of chemical equation. And we already learned about the chemical reaction and chemical equation in our previous class. Now come to, there are some rules observed to write chemical equation in order to express chemical reaction. The rules are, first one, in a chemical equation, the reactant are written on the left side and the product are written in the right side. And an equal sign or an arrow mark is placed in the middle. Now, second one is the reactant and the product are written by means of their symbols and formulas. If there are more than one reactant and products, they are written in the plus sign. And next one is the number of atom of different elements on the left side and the number of atom of the same element on the right side need to be equalized. Look, there is hydrogen plus oxygen produce water. But here two hydrogen, but here two oxygen atom, here is only one oxygen atom. For equalize this we need give 2 here, then there will be 2 oxygen, that means this oxygen atom equalize. But here 2 into 2, that means 4 hydrogen atom, we have to equalize this number, so we have to give here 2 also. That's why we will get 2 into 2, 4. That means here 4 hydrogen atom and 2 oxygen atom, and here there is 2 hydrogen plus 1 oxygen, multiply 2 multiply 3, that means 6. Here also 6, that means in both sides there is 6 atom, that means it is equalized. Now next one is sometimes reaction are not balanced in the equation. In such cases the arrow mark is used instead of the equal sign. That means when we do not make it equal, that time we must give the equal sign. After make it equal, we can give the equal sign. Sometimes the physical states of the both reactant and the products are also mentioned in the equation, like this way. Hydrogen is liquid, so sorry, it is gas, we have to write here H2G plus O2G, and product is H2O, that means liquid. Like this way we can also give the physical states with the equation. Now come to next point. However, if an equation is to show how much heat have been produced or absorbed in the reaction, it has to be balanced in the physical states of the reactant and products to be written. Solid substance carbon react with oxygen gas produce carbon dioxide. This equation is like this way. Carbon is solid and oxygen is gas, and carbon dioxide produce product is carbon dioxide, it is also gas. And solid calcium carbonate react with aqueous solution of hydrochloric acid. Dear student, what is aqueous solution? Aqueous solution is the solution of water and that element, of that compound also. And to produce calcium chloride, gaseous carbon dioxide or liquid water. And calcium carbonate, that was solid and react with hydrochloric acid's aqueous solution and produce calcium carbonate, that is aqueous solution of calcium carbonate, carbon dioxide, that is gas, and water, that is liquid. Calcium carbonate, hydrochloric acid, calcium chloride, carbon dioxide, and water. Some reaction are there, they required heat to applied, and the heat is expressed with the delta sign, and that delta sign shows that we need to apply heat for happening this reaction. And that if we see the delta sign above the arrow mark, that means heat is applied on that element. Which element? That calcium nitrate, that was solid. For reaction we have to apply heat, and after giving heat we get magnesium oxide, nitrogen dioxide, and oxygen. Without heat this reaction is not possible. Now come to balancing the chemical equation. For balancing the chemical equation we will take this equation, that is now come here 1 magnesium I don't give here 2, sorry for that. 1 magnesium, 2 nitrogen and 6 oxygen. 2 into 3, 6 oxygen. Now come here. Here 1 oxygen, 2 oxygen, 2 oxygen. In total oxygen is 5. Magnesium 1, nitrogen 1. That means here oxygen is 5, but in total oxygen in the left side there is 6, and we have to balance the oxygen first, because here 5 and here 6. So make it equal, we have to give first here 2. Then if we give here 2, that magnesium will be 2, so we have to give here 2. Then after that there it will be 4 and it will be 12. For 4 nitrogen we have to put here 4, then it become, now we have to count again how here magnesium become 2, oxygen become 2. Now nitrogen become 4, oxygen become 2 into 4, 8, and here oxygen is 2. In that side 12 oxygen, then 2, 8 plus 2, that means 12 oxygen. 4 nitrogen, 4 nitrogen, 2 magnesium, magnesium is here also 2. That means both sides the number of elements are same. Like this way we have to make the balance of the two sides of a chemical equation, and that process is known as balancing of chemical equation. And there is some rules, that rules you have to learn. The rules from page number 100 that we have to learn, and rules from page number 128 that you have to learn. The total rules you have to learn. Now come for your SW. Dear students, your SW is given from page number 124, that problem, and page number 121 problem. I am writing here on the board. SW3 is page number 121 problems, which is given for doing your activity, and page number 124 problem. Dear students, this chapter is very much important and very much easy also. So practice this chapter at home. Do the SW, submit it regularly on Saturday from 9 AM to 3 PM. Thank you.